This video covers Unit 2B of the Intro to Biotech 2 course. In Part 1, you will learn how to prepare stock solutions and working dilutions. In Part 2, the working solutions will be subsequently divided into aliquots, which will be incubated at 3 different temperatures in order to study the effects of temperature on pH. Here's a list of the core materials needed to perform this exercise. For a complete list, please refer to the laboratory manual. In this exercise, you will prepare 4 stock solutions: 1 molar tris, 0.5 molar EDTA, 1 molar monobasic sodium phosphate, and 1 molar dibasic sodium phosphate. You will then prepare 2 working solutions, 0.01 molar tris and 0.1 molar sodium phosphate. The working solutions will be divided each into 3 aliquots. They will be incubated at a particular temperature, and the pH will be measured. This video demonstration will prepare the items seen in the leftmost column. A 1 molar tris stock solution will first be prepared. From the 1 molar stock, a 10 millimolar working solution will then be prepared. The 10 millimolar working solution will then be aliquoted into 3 tubes. The process should then be repeated for the items in the second column and the third column. To begin the stock solution preparation of 1 molar tris, zero a balance, add a weigh boat, and tare it. Add the predetermined amount of dry chemical to the weigh boat. For 100 milliliters of a 1 molar tris solution, we will need 12.11 grams of dry chemical. Be sure to record all pertinent information on the solution preparation form. To begin the solution, label a beaker and place it on a stir plate. Add a magnetic stir bar to the beaker by adding approximately 50% of the final volume of solvent to the beaker. Begin stirring the solvent. Slowly add the dry chemical. To aid in dissolution, move the beaker around. This will allow for the stir bar to contact all areas of the container. While the stock solution is dissolving, you may calibrate your pH meter. When the pH meter has been calibrated, transfer the probe to the yellow electrode storage solution. You can verify the calibration by confirming the pH of the yellow storage solution is 7.00. When the tris has completely dissolved, rinse the probe and place it in the beaker. Be careful the stir bar does not make contact with the probe or it could cause damage. Allow the probe to equilibrate and record the initial pH of the solution. Begin adding hydrochloric acid dropwise until the pH approaches 8.0. The closer you get to the target pH, the slower the addition rate of acid should become. When the target pH has been reached, remove the stir bar and pour the contents into a 100 milliliter graduated cylinder. Rinse the beaker with a small volume of deionized water and transfer it into the graduated cylinder. Use a transfer pipette to accurately bring the final volume to 100 milliliters. Cover the graduated cylinder with a piece of parafilm and invert several times to mix. Transfer the final solution to a labeled storage bottle. Ensure the label includes the solution name and control number matching your solution preparation form. Next, we will prepare the tris working solution. From the 1 molar tris stock that was just prepared, we will now prepare a 10 millimolar solution. Begin by transferring the calculated volume of stock solution to a 100 milliliter graduated cylinder. With deionized water, bring the final volume to 100 milliliters. As before, cover the graduated cylinder with a piece of parafilm and invert several times to mix. Transfer the 10 millimolar tris working stock solution to a labeled storage bottle. Repeat these steps to prepare the remaining stock and working solutions. We now begin part 2 of Unit 2B. Aliquot 20 milliliters of each working solution into 3 50 ml conical tubes. The aliquots will be incubated on ice at ambient temperature and at 60 degrees Celsius. Place the first aliquot in an ice bucket and begin the 5-minute incubation period. Place another aliquot in a 60-degree water bath. Set another timer for 5 minutes. At the end of the incubation period, place a thermometer in the first aliquot. Allow a short period for the thermometer to equilibrate. Record the final temperature. Transfer the thermometer to aliquot number 2. While the thermometer equilibrates in aliquot number 2, measure the pH of aliquot number 1. When measuring the pH of aliquot number 1, do not remove it from the ice. Record the determined pH for aliquot number 1. Record the temperature of aliquot number 2. Place the pH probe in aliquot number 2. Allow it to equilibrate and record the final value. Transfer the thermometer to aliquot number 3. Allow it to equilibrate and record the final temperature. For the aliquot incubating at 60 degrees Celsius, use the calibrated pH meter near the water bath to determine the pH. As with aliquot number 1 kept on ice, keep aliquot number 3 in the water bath during pH measurement. When finished, rinse the probe and return it to the stored solution for the next user. Repeat this process using the 3 aliquots of the sodium phosphate working solution. Be sure to record the temperature and pH of each aliquot after a 5-minute incubation at each condition.